Hello, the intention behind this video is to give you an overview of Ohm's law. To begin with, I present the statement of Ohm's law. It says that the current through a conductor is directly proportional to the voltage across it, provided all physical conditions such as temperature remains constant. What do we mean by physical conditions? Physical conditions here refer to physical quantities. Anything that can be measured or quantified is called the physical quantity, such as length, mass, or temperature in this case. Something which cannot be measured or quantified is not a physical quantity, such as happiness, sadness, or how much interested you are in learning Ohm's law. So what's the story behind temperature needs to be constant? Conductors that follow Ohm's law, we call them ohmic conductor and otherwise non-ohmic conductor. For ohmic conductor, if we increase the voltage across them, the temperature doesn't change, and this leads to constant resistance. Examples are wires and resistors. Whereas for non-ohmic conductor, if we increase the voltage across them, temperature does change, and this leads to change in resistance. The examples are filament lamp and LED, which is light emitting diode. A video in near future will cover ohmic and non-ohmic conductor and their IV characteristic in detail. So for now, let's move on to Ohm's law. Mathematically, we can represent it as I is directly proportional to V. Here I represents the current and V represents the voltage or potential difference. The proportionality sign is replaced with equal and a constant, and here the constant is 1 over R, which implies that R, that is resistance, is constant. So we have Ohm's law in the form of a formula as I equals to V over R. So the most commonly used form of Ohm's law is V equals to I times R, which is represented here as a worded equation, and here I represented the units. The unit of voltage is volts and the symbol is capital V. The unit for current is ampere and the symbol is capital A, whereas the unit for resistance is ohms and the symbol is Greek letter omega. So here are three forms of Ohm's law. Depending on what you want to calculate, you can rearrange them to make current as a subject or resistance as a subject. So now I would like you to visualize Ohm's law for better understanding via the simple circuit. I have used PHET remote lab to customize the circuit, and I encourage you to go to the website for hands-on experience and play with it. I will share the link below. So here we have a battery. This is a symbol for the battery. The long line represents the high voltage or positive terminal of the battery, whereas the short line represents the lower voltage or negative terminal of the battery. This is a symbol for the resistor and for the switch. These three are joined with one another in the circuit via wires. If you're wondering about the circles, these are the joints where one wire joined with another, like here and here. Here we have an ammeter which is not connected in the circuit, but if I move it here, it will read the current in the circuit for us. Right now, the switch is open, hence the ammeter reading is 0 amperes. So this is a simple diagram for the circuit. I'll switch it to the equipment one. Note the values. Voltage of the battery is 10 volts, resistance is 5 ohms. We assume here that wires offer no resistance, whereas in real life, wires do offer resistance, which is relatively negligible. I want you to pause here and calculate the current in the circuit using these values and Ohm's law. Hope you got this. Now the idea here is to see Ohm's law in action. I will increase the voltage of the battery and would like you to see closely how the current in the circuit changes, while resistance remains constant. Keep an eye on the voltage and the ammeter reading. I'll increase the voltage. Now the voltage of the battery is 16 and the current is 3.2 amperes. I'll increase further voltage. Now the voltage is 25 volts, whereas the current in the circuit is 5 amperes. Let's increase a little further. Here the voltage is 30 volts and the current in the circuit is 6 amperes. We see a trend here. As we increase the voltage of the battery, the current in the circuit increases. The trend which we have just saw, we can visualize it in terms of rate of flow of electrons. So I reset the voltage of the battery back to 10 volts. Now I will increase the voltage and you will see how the speed of electrons in the circuit increases. So here we go again. At 17 volts, the current is 3/4 amperes and the speed is relatively more. You can see here that as I'm increasing the voltage, the speed of flow of electron is increasing. Thanks for watching. I hope this video helps you to better understand the Ohm's law.